this pretty much, and we just sort of have free-form discussions and code sharing, and sometimes have guests. But anyways, a lot of good meetup, Zoom slash Slack things you can participate in TWiML, and it's helped me learn quite a lot. So I hope you all decide to join something in and participate. Okay, so let's go with our first presentation. So AutoMunge. I don't know how we do this, Mia, in terms of switching control and stuff, but I think, Nicholas, you should let everyone know who you are, and then share your video if you can.
Sure.
And your screen.
I'll share my screen. Let's see if...
I'll stop sharing. Maybe that'll help.
Sorry, I don't have system preferences set up, and I think I have to log out and log back in, so I guess I won't share screen. Apologize.
Is there a share screen button on the bottom?
Yeah, but I need to set up my system preferences, and I'd have to log out and log back in. I think I've been through this before. So I'll just defer you to the link in the TWiML landing page for this talk. There's a link to the AutoMunge, and I'll actually paste it in the comments. That way...
What happens, let me ask Mia, what happens if I share, don't start the 2 minutes yet, please, but what happens if I share my screen and Nicholas is presenting with his video? Will that be okay? Will that work? Do we know?
We would lose, yeah.
Okay, I'll share. So go ahead and let's get started while I bring up his materials. By the way, you can link to all of this right from the agenda. So,
well, thank you for the opportunity to share. So I'll just go ahead and get started. I've got a little prepared talk, just about 2 minutes. My name is Nicholas Teague. I'm the founder of AutoMunge, and I've spent the last year building a fully featured Python library platform, which automates the data preparations that precede the application of machine learning. We focus on a specific niche of tabular data, which is somewhat of an underserved portion of the machine learning ecosystem. And we've addressed this challenge with a compromise between manual specifications and automation, and along the way materially improved the traditional Python-based workflow for data scientists working with tabular data. At a fundamental level, AutoMunge is a platform for preparing data for machine learning. I'm oversimplifying, but basically that means raw data is numerically encoded, normalized, and has infill applied to missing points, each of which may be prerequisites for modern paradigms of machine learning, and this is all done automatically. The missing data infill in particular is an important feature of the library in which machine learning derived entries are applied based on properties of the data. As training data sets are prepared for training a model, the steps and parameters of transformations are fit to properties of the training data and then returned in a compact Python dictionary, which can then be accessed to consistently prepare streams of data with low latency, such as could be applied for an inference operation, all with no external database or cloud service required. The tool is more than just an automated encoder, it's also a platform for engineering data pipelines. It's built to be used for both novice and expert alike, and can either be applied as a push button operation under automation, or it can be engineered down to the level of custom defined transformations and even custom defined transformation sets. The machine learning ecosystem lacks uniformity in tabular data preprocessing methods. The goal for AutoMunge is to become the de facto standard for assembling data pipelines. I believe that the implementation has materially improved the tabular data preprocessing workflow, and I'm eager for feedback from users who might be willing to try out this open source library. Thanks to the TWiML community for being so supportive. There's plenty more to come.
okay. So sounds good. Definitely within the 2 minutes. Thank you. So I'll start off with asking one question, then I'll see how what other folks have to do. Can you maybe go further into what sort of the core use case in your life that this grew out of?
Yeah, so I mean, really, it grew out of experiments with Kaggle competitions, and found that for feature engineering transformations applied to tabular data, there was sort of a lack of good open source libraries that could meet my needs. And so that's where really the seed of the project grew. And along the way, I think have made some material improvements to means for applying transformations to features in tabular data, such that we've developed a set of primitives for command line specification of sets of transformations, which really simplify the specification of multi-transform sets. We've also, I mentioned that missing data infill is an important point. So what we have is what we call ML infill. And it's basically an auto ML method in which predictions for missing points are derived based on properties of the training data, so that it's an intelligent prediction for missing data infill. And it's done automatically with just the activation of a parameter.
Okay, now people with questions here, I would recommend that you just shout out, shout it out. I mean, I'll try to follow the chat, but that's a little hard while trying to manage the presentation. But just don't be worried about interrupting or anything. Does anyone have any questions?
Hey, Nick, I've got a question for you. This is Sam. I've followed from arm's length. You're working on this project. Can you maybe talk about did you have some specific use cases that inspired you to develop this?
Some specific use cases. Well, again, it's really intended for the specific application of tabular data, which is data that's available in feature set columns and collected sample rows. So this is really a really common form of data found in business and enterprise applications. And it really, its most fundamental level constitutes two different types of feature sets, those of categoric and numeric features. And we've developed a library of feature engineering transformations that can be applied to these types of features, some that are novel and some that are material improvement on mainstream practice. I'll give an example for categoric encodings. The traditional method of numerically encoding a categoric set is to just kind of a coarse-grained representation of the different categories as one hot encoding or an ordinal encoding or something like that. And we developed methods to extract grammatical structure shared between entries in a categoric set. So we have what we call our string parsed categoric encodings, and those allow for more information retention in the categoric encodings that are presented to a machine learning model. We also have a library of feature engineering transformations for numeric feature sets. And I've actually have a couple of preprints out there for these different methods. Some that include things like noise injection for differential privacy, things like data set augmentation is automated data set augmentation, and as well as things like different types of normalizations and binnings and grainings and things like that.
Are all those things built into the tool, Automon?
Oh yeah, yeah. It's all push button. It's just activation of a single parameter.
Have you had a chance to actually use this in a Kaggle competition, or is this sort of after your time with Kaggle?
Yeah, well, it started on Kaggle. I've documented one competition, the IEEE credit card fraud detection competition, which I documented on my blog in a post called "Is Fraud," and that was last year, around the time that I attended last year's TWiML Fest. Actually, I was just putting the finishing touches on that competition when I was in San Francisco. Come to think of it. But the bulk of the applications now have been for purposes of developing research papers. And I noted that I have a few preprints out there, which are available on my blog.
So you've had other researchers use this?
It's sort of an emerging tool. I mean, I'm not going to.
Yeah.
It's kind of, I've had some early interest. I wouldn't consider it as a widely adopted tool just yet. It's definitely something that I would welcome any opportunity to help get the word out. So that's kind of the stage we are.
Yeah.
So I mean, the GitHub link you sent is not working. Maybe you can check that. I'm getting a 404.
Do you see it on my screen?
Oh yeah. The link in the chat.
Oh, the link in the chat isn't working. Sorry.
Oh, all these things.
If you go to the TWiML landing page for this talk, there's a link under the session 1 for the cover brief, and that's what I was trying to link to.
Yeah, I'll also post at least to the README. That should get you to everything, I think.
Yeah, that's the GitHub.
Oh, is that, yeah, that's right. Yeah.
So it's fully documented on GitHub, and it's also has been documented in a series of essays, which I've been publishing over the course of the last few years, kind of documenting the development process. So I kind of have been writing essays parallel to developing the code, and it's been kind of mutually reinforcing. I find that the more I document, the better my code gets, and the better my code gets, the better I document it. It's kind of a virtuous cycle.
And where are those essays? Is there a link to those?
Yeah, if you go to automunge.com, and I'll put that in the chat.
Okay.
It's linked from
I'm also showing it to everyone right now. So. Okay. I mean, at this point, we have over 5 minutes left. I was hoping, does anyone have any other questions or directions you'd like to go with this? Do we want to look at a little more detail of a specific feature or function, or ask more general questions? What do y'all think? Somebody shout out something.
Yeah, so one other question that I've got is the degree to which this works with other things that folks might be interested in using, like just for example, with the Fast AI, a lot of that course looks at, or at least some of the course looks at tabular data. Is there a way to use this with the things that they, the approach that they take in the course with the Fast AI library? And then, more generally, are you choosing AutoMunge, versus other libraries that might be helping you do similar things, or have you explored interoperability with those things?
Yeah, and you mentioned FastAI. I'll note that one particularly, that the last research paper I published was called A Numbers Game. And in the experiments for that paper, I did work with FastAI library in conjunction with AutoMunge. So AutoMunge is a way to think about it, is it's intended in the workflow as the step immediately preceding the application of machine learning. So it's tabular data pre-processing. And it's just like how when you train a model with a machine learning library, it returns a model that you can save and later access to run inference. When you process data with AutoMunge, it returns a dictionary that's kind of fit to properties of the training data. It's such that it allows applying that dictionary to consistently prepare additional data with just a single function call. And in the context of like a FastAI workflow, for instance, it's definitely suitable as a precursor to the application of the FastAI. And the kind of FastAI has a philosophy that they don't really overthink tabular data pre-processing. And so we kind of have taken a different philosophy that there's room for more intelligent methods of extracting structure from the pre-processing methods prior to the application of a model training operation.
Does anyone have any other questions? Someone out there with experience with tabular data, what sort of tools you guys use, and how this might fit in? Although we only have about 40 seconds left, but I mean,
well, I'll just close real quick with just a short, summary. If we only have 40 seconds, basically, I just want to highlight that this is, I'm a professional engineer, and I've really approached this with the diligence of trying to make sure this is a robust and bug-free tool. And I really am comfortable with the implementation, and I really feel like this is suitable for even industrial applications. It's basically intended to be applied as a precursor to machine learning. And it's all in the compact Python library with no external database, no external cloud service required. And yeah, I'm definitely welcome any feedback from people who might try it out. And I'm happy to answer questions, happy to solicit feedback on what is confusing or what might need more clarification in that particular I'm interested in. But thanks for the opportunity to share. I really appreciate it.
Thank you. I would say that it would be interesting to have another session with one of the groups that meets regularly to actually have a demonstration of the details of the capabilities, such as those categorical capabilities you presented, because that would give people a really, visceral understanding or intuitive understanding of how it might come in handy, and that way when they're in the situation they may think about the tool and give it a shot. So
yeah, for the categorical,
sorry we only have 10 minutes.
Features that I noted, I just call out that there's a paper I published available on my blog. It's called String Theory and Categoric Encodings with Automunge. And that's a good summary of the types of novel categoric encodings that are available.
Okay, great. Thanks, Nick. We'll hope you enjoy the rest of the presentations as well. So we'll move on now. Thank you.
Mm-hmm.
Yeah, people feel free to put up the clapping hands or do something, so we know you're out there. Okay, so our next presentation is measuring gender bias in Spanish language models. I know there's 2 notebooks that go along with this. I know that I was quite interested in getting a little more information on the second notebook, second set of code as well. Now, Nick, please let us know where you're at and who you're affiliated with, and then go right in. Jump right in, please.
All right, let me share my screen here. Okay.
Good. Looks good. I see it.
All right, I'm Nick Doran. I'm a software engineer at Tufts University in Boston, and I've also been doing some freelance and side projects in NLP, which is how we get this project on measuring gender bias in Spanish language models. So some background, if you're not familiar with NLP, we're working with text. The way that it works these days is you have a giant word cloud of all the words as vectors, and it's been discovered that these vectors have meaning, that you can show like analogies like man and woman and king and queen are parallel vectors. And in English, the ways that people measure bias typically are something like saying, oh, is there a vector difference making he or she more likely to be a doctor or a nurse or a journalist, or building your whole model and then making counterfactual sentences saying, if I change this person's name, if I changed he and she, would that sentence prediction output of the model change for bias measuring? In Spanish, it's going to be a little bit different because so many nouns, adjectives are gendered. So very quickly, what I did was I took a typical test for English and made 2 parallel lists. So él is compared to professor, and ella is compared to profesora. So we're looking at parallel words and making sure that we're not trying to like cross paths in that measurement. And then the second thing is to generate counterfactual sentences. You can't just change one word. You have to change the entire, basically the entire sentence. So actor becomes actrice, and then anything that's connected to that word also has to change gender to generate a counterfactual sentence. For that, I'm using Beto, which is a monolingual Spanish model, and Spacey, which I think people are more familiar with, which has a lot of details about the different words. Words which are not gendered, like la biblioteca, are not changed, and then there's some other words that work in different ways, which are kept the same as well. I did this analysis on Beto, which I mentioned earlier is a monolingual model, and Google's multilingual BERT, which is a multilingual model, it has 100 languages. So there's some differences that came out of my results of, is there bias or what kind of words are most associated with people, depending on whether you're looking at the monolingual or multilingual model. So that's kind of interesting because there could be other information coming in from other languages affecting what's happening in your language and the bias of your model. Future goals, I already did some data augmentation with this, like flipping sentences and then adding that to my training data. One task it worked really well, one task it didn't work so well. I would like to, instead of using spacey and being kind of very deliberate and programmatic, have some kind of like deep learning neural way of generating the counterfactual sentences, maybe with sequence to sequence. And then
hey, Nick, I think that's up. Sorry to
yeah, that's
interrupt you.
out of time. Okay,
But
so yeah,
we
you
need
can
to keep
see the
it
rest
short
there.
because there's a lot of presentations, so we need to keep it on track.
No, for sure.
But we'll definitely draw that out. So does anyone have any immediate questions off the top of their head? Has anyone here done any work in biased models in any language, or have any experience at all with word vectors and doing this sort of bias analysis?
I had a question about, you did this in Spanish, and I know a lot of folks are looking at word vectors and NLP and trying to figure out like how do you tease apart biases. Did you find that doing this analysis in Spanish gave you more insight into the models than you might have seen if you'd done it in English?
Absolutely, because I'm sort of trying to find out how can I make this kind of, like you can see on my screen, kind of how can I make this kind of analogy to just go between the masculine and feminine version of a word. And what happens if I try that, but there isn't a counterpart word like biblioteca? And so basically running this would just go to whichever is the closest. So it might be, it turns out that the plural, singular, masculine, feminine, they're all kind of very close together in the vector dimensional space. So if you don't have a counterpart in the masculine feminine words, it'll usually jump to the plural, and I can detect that and be like, well, I'm not going to pluralize the word in my test, so I don't change the word if it jumps to the plural.
Did you have follow-up on that? Anyone?
Thank you.
Is there anyone who would like to?
Could you summarize the bias that you found? I'm not clear what was the bias you found.
Yeah, so the thing is, knowing how this translates to actual bias is very complicated, but the way that it's being measured in English is something that I would like to extend to Spanish. So the way it's being measured in English is seeing, let's say in the vector space, it's a lot more distance to say that a man is a nurse versus a woman is a nurse. That reflects some existing numbers in reality, but I don't know if in our language model we want to tell our language model that there's this bias or this difference. So it can be measured by saying, literally, is there a vector distance between these two? And does it matter? And so there's a test called WEAT, W-E-A-T, let me see there. And they have a list of positive and negative adjectives. They have a list of scientific careers and artistic careers. And they have a list of masculine and feminine things like son, daughter, like, oh, my son is a doctor, my daughter is a doctor, and compares, is there some kind of distance when you make that sentence into the NLP model? And it wouldn't make sense to say, my son is a doctor, my daughter is a daughter in Spanish with the same word for doctor, because that word's going to change. So I've created parallel words, and then we measure it. And then I looked at when people get these numbers for WEAT, what do they typically do? And they create these box plots based on the words that were in their keyword list.
Can you show real clearly, either there or in the notebook, one? We don't have a lot of time, so one specific example of the bias? Because I can't see here; it's too small, and also,
yeah,
I don't know. This is all in the notebook too, I think.
Yeah, there's notebooks for more things, but what I would show here is, if I can move this little.
Yeah, make that a little bigger if you can. I mean, I could sort of, the plot itself is hard to see.
Yeah, let's skip over the box plot because it helps to have seen like other box plots about this. What's important here is on the left side, you can see that masculine and feminine word associations like Nino and Padre are very close for both of these models. And then one of them has careers that are very closely associated with it. And the other one has fewer careers associated with it. These are the most closely associated words for the masculine and feminine word list in these two different models. So it's hard. I'm not saying that this directly means your model will be biased, but really the first part of saying something's biased or not biased is just figuring out how do I measure this. And one of them is having, so I've just been following what do people do in English and then trying to extend that so that it's still possible to do even when the language is so different.
So we have one chat question. So you did observe some bias, so I think then the question would be, do you have any thoughts on how you mitigate your model for bias? Do you have any experience or any ideas about that?
Yeah, so I'm
Particularly in
talking to the professor who made the Beto model. He's at the University of Chile, and the one idea was that you could get all of your training data and flip it to the counterfactual, so you have an equal number of masculine and feminine sentences. One option is kind of, I was getting at the end there, in Spanish, there's this emerging trend of using at for O and A endings. So potentially you could have some gender neutral Spanish that you could have, and then whatever your model inputs could be then neutralized before going in. But I don't have that experience yet. It would definitely take a little bit more effort, and to generate so much data, like all of your training data, probably you would want to have some kind of really fast program that does that really well.
Yeah, I think some of the data augmentation techniques might be interesting to use. Not that I have any experience with this area, but does anyone have any experience with bias or with mitigation, or just any brainstorms on how to mitigate or observe? Or any other questions in general? I think we still have about 4 minutes.
And I would also like to, hopefully in the future, there's something called winnow gender, which has some different sentences in English to see whether it assumes he or she, or which person, or the different tests that can be done in English. And so it might be interesting to adapt that to Spanish. This is just an example with Google Translate where I was able to trick it into choosing whether the doctor was he or she in the translation.
Questions, thoughts?
It'd be interesting to see, like, based on your work, the sentiments around some of the female-male words. I think in the past, things like, el puente, the bridge, there are sentiments of you being strong and heavy and because it's kind of like a male puente. So it'd be interesting to see if this could be adapted to like analyze sentiment to that specific word.
Right, even like an inanimate object, like you're saying, or a place could be perceived as more masculine or feminine. That's kind of an interesting thought. I haven't really looked into that.
Nick, you want to? Does anyone have anything else? Maybe something in the notebook, people you want Nick to show?
I don't have the notebook open right now, but yeah, definitely. If this is something you want to do a deep dive into, what does the code look like, and what is WEAT, and where's the GitHub for all this stuff? It's all there in the notebooks and the GitHub gist, which is on the agenda for this session.
Okay, so what are your next steps with this work?
Next steps, I'm glad that I was able to show it to the university in Chile, because they have people who are kind of working on this more full time and might influence their model. I think I would like to study the data augmentation thing more, because language is, you just download Reddit comments, it's going to be biased in some ways, but data augmentation is just something that's going to be useful for everybody, and can kind of, it just would be nice if I could have it in like a sequence to sequence kind of way, rather than the way I have it now is kind of a hacky Python script with spacey. So I'd like to make it more deep learning-y in the future.
Okay. And are you a student?
No, I'm a software engineer. My main job is on redistricting. We have a website that helps people do US congressional districts.
Wow.
But
Oh, wait, we got to have you come talk about that one. That sounds interesting. Wow, what a problem.
unfortunately, there's no machine learning in my work with that. But yeah, it's going to be a pretty big problem coming to you next couple of years. Some more politics to look forward to.
And what organization is that with?
MGGG, we're a group inside of Tufts University.
I see. Very good. Okay. And all right. Do you have any other experiences with bias stuff? Well, what led you into this?
So many years ago, I worked with One Laptop per Child in Uruguay. So I have a little bit of Spanish knowledge. And when I read a paper about discovering bias in English, I thought, well, that wouldn't work in Spanish. You would get all sorts of strange answers out of it, right? So I thought, and then there are other languages that use gender as well, which I thought, if no one's documented this, I should kind of throw some stuff out there and see what sticks. So it's been kind of interesting seeing this reaction. And then there's also, I've discovered a paper that someone wrote that was about Spanish and also Hebrew, which had some gender counterfactuals in it. So that was interesting to see.
Okay, well, thank you for sharing. I keep up the good work. This is very interesting. And we're going to go on to the next presenter. I hope you enjoy the rest of the presentations. I'll take the screen.
All right, thanks.
And thank you. All right. I feel like we should stop and do some jumping jacks or something in between these. Need a little time to absorb. All right, our next presentation is machine learning for encrypted traffic behavioral modeling. It looks like a supervised learning problem. Abdul, you'll have to straighten me out if I missed that. There are notebooks and code, and let's go for it, Abdul. You ready?
Yeah, I'm ready.
Take the screen.
Hi, everyone. Hi.
You're a little low. Your volume's a little down.
Okay, is this clear now?
Oh yeah, that's a lot better.
Yeah,
Thank you.
fine, yeah. So I'll share my screen now.
Okay. Perfect. I see you. Not the screen yet. Now the screen is coming up. There you go. I see it.
Yeah. Hi, everyone. My name is Abdul, and I work for Hewlett-Packard Enterprise. And I'm going to be presenting on machine learning for encrypted traffic behavior modeling. In this era of Internet of Things, we have a growing number of devices and technologies generating network traffic. With this growth, it has become important to manage this traffic at the edge for the purpose of visibility and security. So my solution to this problem is to use statistical properties of a flow from a packet header and train a residual network to classify the packets. And the key point here is we are going to use data from the packet headers and not the data itself. So there's no privacy concerns here. So why did I choose ResNet? It solves the vanishing gradient problem in deep networks. And we know the deeper the neural networks, the better they are at classifying more complex data. It gives us a general framework and the ability to model nonlinear relations and achieve more expressiveness and generalization. The most important point here is better scalability. So I'll just go out. I'll tell you how the data set was. So we had around 34,000 rows, and these were the 6 features which we chose. The features are mean packet length, standard deviation in packet length, mean interpacket arrival time, standard deviation in interpacket arrival time. We have a forward packet rate and forward byte rate. So the classes here, you can see they are numbers, but actually these numbers are mapped to different protocols like DNS, HTTP, and etc. ResNet, as you know, like some people might know, it is usually used to classify images, and they have like really good results. They've given really good results when you classify images with them. So my approach here was to convert this tabular data into an image format. So each integer there has been converted into its 32-bit form, and as you can see, 6 features, 6 rows, and each row is 32-bit map. So this was fed to a residual network, and as you can see on the top left, we have the accuracy. We have a total accuracy of 95%. And most of the classes, except like class 0 and class 2, we have class 1. We have more than around we have around 90% accuracy. And you can see the map, which is mapping the numbers to the class name. Class names are just the protocols. And
Okay, thanks, Abdul. That's 2 minutes. I know it's ridiculously short.
Sure. Yeah, it was the
So,
last
but you
slide anyway.
actually, I think you really covered that pretty well. At least
Yeah.
you know the whole outline. So, congratulations on that. Okay. So, does anyone have anything immediately pop to their head they want to ask?
Yes. So you used ResNets for classifying this, and this kind of method to convert this tabular data problem to a
Image.
image, yes. And so what I understand is that those kinds of convolution networks like ResNets are so good because they can find these spatial correlations in images. And I was wondering how this data is spatially correlated in this kind of image transformation you're doing. So that would be interesting.
Okay, so basically what I did was, see this image, the thing I'm showing here, this wasn't exactly the map which we used. We just have, so I said 32-bit integer for each feature, right? So we have 6 into 32, that's 192. So our image is just a single pixel in height, but 192 pixels in width. So that was the image which we used. The thing is, I tried different permutations and combinations of mixing and matching these. So they're in no particular order. Any order I choose, I got a real nice accuracy. So that's why I've used it like this.
So that's very interesting because there is. So when you say you just do this transformation and there's no specific order to it, then I would expect that there is no spatial correlation between features in this picture, right? But still, it works so good.
Yeah. I mean, that is one inference which we can take. I open this to show you what is the input bit map. So as you can see here, 34,803 rows and 192,1,1. That is the image dimensions.
Mm-hmm. And how does it compare to approaches for tabular data, like, I don't know, gradient boosting or even neural networks for tabular data?
The last slide was for that only. So as you can see, when you use around 10 layers, 8 layers, and 7 layers, you were getting 90% accuracy, right? But I talked about scalability before. The point here is that a smaller neural network will give you the results, but from the results which we see here, there is a vanishing gradient problem when you use really long neural networks, right? So these aren't residual networks. These are just normal MLP, multi-layer perceptrons. And as you increase the number of layers, the accuracy decreases, even though the data remain the same. So the point here is that we can use ResNets as a generalized framework. So my point in saying this here is that even though the input, let's say the data is not complex or it's really complex, ResNets will save you a lot of time, and it will give you a better accuracy. It will be a more general framework.
Okay, understood. So it's not necessarily about accuracy, but about training without vanishing gradients.
Generalizing.
Okay.
Yeah.
What was traffic class 1, and why do you think that it performed so much poorly than the other traffic classes?
Yeah, so I think I have a straightforward answer for that. As you can see here, the traffic class 1 has really low support, right? So the number of training examples were really less when compared to the other classes. So that is why I think class 1 and class 1 has the least accuracy.
What is class 1?
Class 1 is FTP, file transfer protocol.
And what's the other one that was low support?
The other one is HTTP.
Okay. How did you get your training data?
So training data is it is it's a standard data set. If you just type NIMS data set, we have it. But the thing is, this site seems to be down exactly today. I don't know why. It's a network information management security group. So this datagram has been used by a lot of people for a lot of projects. So that's why I chose this. And for some reason, this doesn't seem to work today. But yeah, it used to work before.
And have you been able to apply this at work? Oh, you didn't say.
Uh,
I think you did. You didn't start with where are you? Did you start with that? Where are you at?
Yeah, I'm
Yeah.
working for Hewlett Packard Enterprise,
Yeah.
basically for Aruba networks. So
Yeah.
I'm working in the networking division, and basically we just want to bring intelligence to our products at the edge, not at a data center, because some people don't want their data to leave their systems, right? There can be privacy issues and everything. So this is to run machine learning and analytics at the site of the customer, not at our side.
And what do they do with this? I
Uh,
understand they classify the
yeah, yeah,
traffic,
yeah,
but then
yeah.
what's the use of it, real quickly?
Okay, so there are two things, right? Two things. One is visibility and one is security. Let's say for some reason some customer wants to know at what time of the day, what type of traffic reaches his servers and what people do with his systems. And one more thing is security. Let's say some application claims to use telnet, but its behavior corresponds to something more like a DNS or an FTP. So depending on the use case or depending on the scenario, it could be a security threat or not. So that is the application here.
We have a question in the chat. Are there other architectures that you experimented on? Yeah.
Okay, so the other architectures, no, I haven't. The thing is, I started this by simply making my own models and testing out the data set and everything. And I have made models which have 7 or 8 layers, which perform really well. But I chose ResNets because it has been proven that ResNets work really good for images, and in various competitions and in various places, ResNet many people have used ResNets. That's why I chose ResNets here.
Okay, other folks, questions?
Is ResNet something that, given the edge deployment model here, what does the inference time look like? And is it something that you think you could actually do on an edge device with ResNet for this problem?
Yeah. So the thing is, TensorFlow is available. So to run TensorFlow, you can't run TensorFlow. You can run TensorFlow on your PC, but let's say I have a switch made by HP, and as of now, we can't install TensorFlow and everything there, right? So I did write my own program to manually perform the calculations to perform this classification, and so ResNet 50 is the smallest ResNet layer I used here, and even ResNet 50 did show up some really nice accuracy. And calculating 50 multiplications and 50 operations is not much of a overhead, and it's possible to do it on edge devices.
I mean, the pictures are pretty small, right? So
okay, yeah. I mean, here.
No. I was talking about the inference time, because the pictures,
192
the generated pictures are pretty small, so the computational time is not that big.
Okay, I haven't given the computation times here anyway. I'm just that was a separate experiment. I haven't brought it into here.
No.
We do have a question in the chat. How did you choose the features, and did you not use some features, and how did you figure that out? And were there other things you decided
Okay,
not to
so
use?
feature selection. Okay, yeah. So actually, there are a lot of features in a packet, right? These features are chosen after performing something called principal component analysis. So there is this tool called which you can use to do the principal component analysis. And the thing is, I've chosen I've done multiple experiments. I've chosen the top 6 features. I've chosen top 8 features. I've chosen top 12 features, and these 6 features give the accuracy is comparable. So why use more features when these 6 can give you can also give you the same accuracy? So that is how I came with these features.
Thank you. We have just a little bit of time. Any other questions? What's next for you with all this? Is it in production, or is the next step getting it in production? Do you have any other big ideas to do something new?
It's still not in production, but yeah, they have been internal hackathons, and we have showcased this, and there is interest from people all around. And our plan is to work on this, better this, and one day it will be working on the customer systems.
Great, thanks. I guess you guys must have a pretty good internal culture for machine learning, because I think there's at least 3 people from your, you probably know the folks, so I don't know, it's probably a big organization, but I appreciate all you guys wanting to present. And you, thank you, this is very good. So I think time's up, and really interesting. Okay. All right, so let's see what's next. Okay. So we're doing pretty good in general. We're 50 minutes in. We have Kai is next, keyword image classification. Yes. And I got to tell you, Kai, when I was looking at all the pictures in your notebooks, it did make my mouth water, right? Bad, unhealthy food. Thank you.
Yeah. So maybe we heard now three very fancy presentations. This is more of a fun little thing. So let me share my screen.
Yeah, this would be second only to a cat classification, right?
Yeah. All right. Share. Right. So can you see my screen?
Yes. Again, tell us where you are, who you're affiliated with.
Yes.
Real quickly. Thank you.
All right. So my name is Kai. I'm from Germany, and I am working now quite some time on data science and AI use cases in industrial settings. I've worked for corporates and founded a startup. And as of November 1st, I will be head of industrial solutions at CodeCentric, which is an IT consulting company here in Germany. Yes, so I wanted to share this fun little notebook of mine. It's really just a simple little demonstration. And basically, it enables you to get an image classifier just by defining keywords of the objects you want to find. And you really just have to define those words, like cat or dog, or I've used hot dogs and corn dogs. And you end up with a ready-to-go image classifier. And it uses, in the background, the Google image search engine to find those pictures you defined with your keywords. And I mean, this essentially gives you the ability to extract AI models from Google's image search engine, which is kind of cool. And it's really pretty just straightforward. You just have to install some packages, define your keywords, like hot dogs and corn dogs, and the pictures automatically get downloaded. You have to define this here and how many you want for this, and get saved into folders. Then there's a little snippet that cleans the data, sort out corrupt images, and create a validation set. And I mean, you can also do that with the FastAI API, for example. And then the rest is really just straightforward, boilerplate, FastAI image classification. And I mean, it works really well. And you are using basically the best image search engine in the world to collect your data. And I mean, of course, obviously, this will not work with medical images, for example, but I do think that this, at least for your private little projects, can be helpful. And that was 2 minutes or shorter? Darren, I can't hear you.
Okay, can you hear me now?
Yeah.
Perfect, dude, perfect. So go ahead, Shri. There was a question. Anyone have questions, ideas? So, I mean, look, I could. Can you hear me, Kai?
Yeah.
Okay, great. So I can immediately see why this would work, is because as long as you're searching on, fairly large volume popular areas, right? Because you're going to get your first 1,000 will even be good, and that's enough to train something for sure. Can you imagine this being used in an industrial machine learning situation?
Well, I mean, I think that it can help because, so in the last years, I've been working a lot on industrial radiology, for example. So for this application, I don't think that it could help. But generally, I think that people underevaluate pre-training and stuff like self-supervised pre-training of your base model and stuff like this. And I think that this can help when you, I mean, the data set is probably messy. You can see like here is a pizza in this data set, which does not belong there. But generally, I think that when you can do something and find something similar with Google image search, or even some pictures that are in the same area, then maybe it can help with pre-training your model when you have a small data set. So I think that it can help. And also, if you really just want to do a fun project for your own, maybe a pet classifier or something for your private purpose, then this can also be a fun thing and easy thing to collect data.
Anybody? Does anyone have any experience?
Just 2 classes, or
Yep.
can you do a bunch of different keywords at once?
You can do however much classes you want. There is a limit of 100 pictures. And when you want to have more, you have to install the Chrome driver. You will find the code here. And when you install this, then it's kind of emulating a browser in the background, and then you can download as many pictures as you want, because I think 100 pictures is the limit that you will see on one screen, and then you have to scroll down to kind of unfold the next images, and that's what's emulated here. Also, yesterday I tried to port this to FastAI 2, and the image downloader package is currently not working because Google changed the response package for the images. So you have to either fix it on your own on the package, or wait until someone fixes this.
Can you make those images, the page, the section there with the images a little larger? I can't. I mean, I can't really see it very well. Yeah, make it bigger. Well, look. So those images that are returned. What's that?
Planning your lunch.
Yeah, exactly. I'm drooling on my mic. Don't look. Yeah, the numbers. So I guess I was unfamiliar with this. This is your predictions, where you're predicting images. And what are the numbers on top there?
So this is loss and predicted probability of, I think probably hot dog or corn dog.
I mean, they're going to go from top to bottom in terms of highest or lowest loss or highest accuracy.
Yes.
So
yeah.
the 1.9 must represent a good number.
Top loss, yeah, probably. So I think this is maybe confused for corn dogs. It is fish, of course. But I think the confusion matrix shows that it can work pretty well. It's, I mean, the test set here is just 20 pictures, but yeah, I mean, it has to be pictures. Sorry?
Sorry, no, sorry, go ahead.
And you have to choose for, of course, pictures that you will find via the Google search engine. So where you really, I mean, just like I said, if you try to find radiology pictures, it will not work.
Yeah, one thing that I've seen with things like this. Hi, this is Alan Coppola.
Hey.
And one of the things I've always seen with things like this, it's kind of interesting because you're kind of relating the words, you know, a corn dog, and you're hoping that you're going to get pictures back that have the corn dog pretty much centered right in the middle of the picture, so you don't have to do like a lot of you know, saliency checking and finding the region where the corn dog is. Correct?
Yeah. Yes, but I think it's more like, imagine you have the task. I mean, it's a funny task, but you have at work the task to train a classifier to find corn dogs and hot dogs, and you only have, I don't know, 20 pictures or something, but your boss wants you to train this. And then I think that when you use this kind of messy data to pre-train the model, you will get much better results when you just try it with 20 pictures without pre-training and just use a pre-trained ImageNet model.
Yeah,
so
no. This is cool for that purpose.
Yeah.
Application that I was working on a couple of years ago was, you know, they have trail cameras, and this one client wanted to find out the bucks from the does. So from trail camera, you know, stuff in the wild, you want to check out which pictures have the horns in them. And so I did something like this, and of course it took me like 5 times as long as you just did it. But
Yeah.
anyway, the point was I found a lot of images on the internet of bucks, right? And I trained it. I was really happy because it worked really well.
Yeah.
Did you have to do any further processing on that, Alan? So you basically got the images off the web. How did you do that? And then did you use other techniques like data augmentation or just other ways of validating your training
Yes.
set?
So it's really just downloading the pictures from the Google. It's the same pictures that you would get when you type in these words into the Google search engine, into the picture search engine. And then the only post-processing thing is just cleaning the data, just going through the images and see if they are corrupt or not, and then sorting them out. And then for augmentation, you just basically do all the same things that you do with any type of image data set. And I mean, that are just normal pictures. So you just can take for example, when you use FastAI, the get transforms method, where you have all kinds of nice augmentations that work well for those kinds of pictures. Yeah.
I mean,
how about you, Alan?
Well, I'm just to answer what Kai is saying. One of the things is like what I'm just trying to say is that the word, when you do a Google search and you use words, you're actually getting you're actually getting images back which are already are already regionized for the actual object, right? Which is cool. That's good. And so, for example, suppose you put in fast food instead of corn dogs, right? Well, you get a bunch of crowd images of people or maybe you put in party or something. I mean, and they're eating corn dogs or something. But the point is that this works really great, and it's really neat because you're just scraping images from Google and you're using a word. You're using the words that are close to what you're trying to find, so it's the perfect application for it, which is great.
Yeah. I mean, you're
wondering about this is just looking at these images. So you do a search for corn dog, you get a bunch of corn dog images, you get a few box images, you get a pizza image apparently, and some fish sticks. And I'm wondering if you can envision a way to either do outlier detection or clustering or something so that you can automatically refine to what the main image that you're looking for might be.
Yes, sure. So, I mean, those pictures you see here in this grid are the top loss pictures. So that are the pictures that have the biggest loss, which means that they are the worst classified. The classifier is the worst certain that a corn dog or a hot dog. And with this, if you take, let's say, from 100 pictures, the 20 top loss pictures, and then you look through it, you will find pictures like this, which is not a hot dog or a corn dog or the pizza. And then I think you can iteratively kind of sort out some of the pictures and you get a better data set. But in my experience, it is not necessarily bad if you have a little bit messy data set. I mean, it's the pizza won't help for sure, but it does not hurt that much.
It's actually not a bad idea for validating in general after you've done everything, all your formal stuff, because real world, it's more real world.
Yeah.
So we just have a short, about 30 seconds left, but there's a question, is there a way to visualize weights? So for example, how many weights between -1 and I think it's supposed to be 1 in Gaussian style? Does it?
The weights of the model of the any way to visualize weights? I think it's
probably the ranking. Probably the rankings. I don't know. Kirti, if you want to speak up or something.
How many weight values are zeroed? I'm not quite sure I understand the question. Maybe if you want to follow up on this, you can post that on Slack, and then we can discuss it more. I mean, the 10 minutes are over, right?
Yeah, it's up. Sorry about that.
No problem.
Maybe I misread it or something. So anyway, Kai, thanks.
No, I read the question.
Okay.
Just copy it and post it over at Slack, and then we'll discuss it there.
Thank you. That was a fun little and very useful and interesting. And Alan, thanks for sharing that also, that use case. That really
Thank you.
Puts things in context as well. So, all right. Well, I guess we're ready to go on to the next one. let's see where we are here. We got our last one, and we're at an hour and 5 minutes. 5 minutes. So I think after this one, I'll open it up in case there's other general questions, because we'll have a little bit of time. We can go an hour and a half if necessary. We can go to 9:30. So if you have further questions, hang on, or things you want to share, your experiences just in general, we'll go for a little bit longer. But this is our last formal presentation here from Shri, exploratory analysis of SVM support vectors. And please go ahead. Let us know where you are and what you're affiliated with. Thank you.
Yeah.
And share your screen.
Yeah, hi, Darren. And thanks
Hey.
for the opportunity. I'm Sri Pani from India, working with HPE on Aruba portfolio of switches, basically a network domain. So just a minute, I'll share the screen, share my video. So I have been working with my colleagues on this particular idea. We have just started working on this. So just wanted to share this idea and feedbacks and just on that. So we all know that SVM algorithm is basically used for classifying the objects, which classifies based on the decision boundaries it detects between the classes, right? So as the number of support vectors increase, it will be very difficult for us to interpret and understand the decision boundaries between each of these classes. So the main idea was to reduce and determine only the minimal set of supporters that understanding the hyperplane in each of these classes. So the approach what we actually followed was we have this data set and generate a model using any of the SVM features. Now we'll cross-validate this particular model and get the number of support vectors, accuracy, and confusion matrix. Now that the number of support vectors, next what we do is we move the support vectors from the original data set and then retrain a new model from the rest of the data, which does not have the original support vectors. And then we regenerate the model, identify the cross-parity accuracy and the confusion matrix. Now we repeat this process until we find a way that the accuracy and the confusion matrix of the model is not deteriorated. So we have performed this experiment on the IoT malware data. So and we observed that the data set had 346 unique vectors. We just tried it out. 346 unique vectors. When we trained this particular model on linear SVM, figured out there were 157 support vectors, and the percent with a very good confusion matrix results. And then when we removed these support vectors from the original data set of 346 vectors, and then we retrained the model, we found that the resultant support vector score was reduced from 157 to only 6. And these 6 support vectors have generated the decision boundary between these two classes. We basically trained it only on binary class, which are benign traffic and IoT malware. And found that in these 6 support vectors, the accuracy was still maintained at 59% with even much better confusion matrix. Only around 9 vectors were misclassified out of 346. We found out that varying these C constant parameters, which is the optimization parameter for linear SVM, we varied this between 100 and 1000, but still we didn't see that the accuracy improved a lot. But by following this exploratory approach, support vectors, we were able to develop a model which gave almost same accuracy as per that the original data.
Okay, I think that's 2 minutes. That's great. I think that's a good overview. Is there anyone who has a question right off the bat or experience with SVMs that would like clarification? There's one thing I'm missing. What does explainability mean in this context with an SVM? You know, whether you have 156 support vectors. I think those are also called hyperplanes, maybe. What does that mean when you're, you know, like now that you've reduced the hyperplanes? Give me an example of what needs to be explained and what you see, and how this helped that.
So the data set what we chose, right? So initially we chose these two. This was distribution of the data, which are showing attack-based malwares, right? And then the linear model, since the data, this data is clearly with the linear model, we chose linear algorithm. And then if you see these results, confusion matrix results, right? So these support vectors initially, 1 minute. Yeah. So these support vectors, these were actually the support vectors which were selected by the model. And then since this, these vectors which overfit the model, we just went ahead and removed these support vectors which are close to the hyperplanes, and we retrained the model without having these vectors, which generated another stuff. Did I answer the question?
What was the classification task that you were doing this within context?
What?
So what was the classification task? What were you trying to classify?
We are actually trying to classify if the IoT network traffic is a benign traffic or it is a traffic generated from devices are actually infected with malwares. So, and
yeah,
we
sorry,
have chosen these
I couldn't hear you.
features like
I couldn't hear
package
you. You're coming in and out, so I couldn't hear
you.
you.
Your voice is really cracking too much. So can you please rephrase that use case again?
So actually this particular approach IoT malware dataset, the traffic dataset generated from the IoT devices affected with these Mirai variants of IoT malwares, right? So we had this dataset chosen from the Stratosphere laboratory, and we were able to figure out those traffics which are normal traffic and the benign based traffic. And the entire dataset had 346 unique vectors with PPS and BPS as the two initial features which we chosen for our approach. With these two features, with these 346 vectors, we trained linear SVM model and found out that the initial set of support vectors identified were 157. And we wanted a way to reduce this number of support vectors so that we can easily understand the hyperplane, the distinction hyperplane between these two classes, attack and bin. We removed these 157 vectors from the original 346 data, and then that had 189 vectors, right? We retrained the model with 189 vectors, which resulted in 6 support vectors, and then this second model we cross-validated against the 346 vector dataset. So that is the point here. And that cross-validation still resulted in same 89% without any declaration.
So can you please sum that all up in a small sentence, because I'm really not able to hear you properly. Your voice is too much cracking.
I'll try to do a little bit. I mean, obviously it's a binary classifier, right? Judging between benign benign traffic versus an attack, right? That's the task.
Yes.
And was there more you didn't hear that you want me to repeat?
So actually, you aggregated all these 3 model values, right? I mean, the model 3.
I'm sorry, say that again?
I'm saying that he aggregated. Did you aggregate those 3 model data? I mean, you train on a particular data, and then you train on the rest of the data.
Yeah,
like
yeah.
So
when I
so you're like ensemble all that,
so
right?
when I yes, correct. So when I calculated the cross-validation accuracy, this was always against the initial 346 vector data set. Even though it was checked for 189 vectors.
Okay. So is there any kind of overfitting?
Yeah, it was
What did you
waterfalling.
do to
So
try to
now
improve
the
that?
future plan is to
Go
now
ahead.
the next steps what we're planning is to work on other kernel like RBF, etc. And for other domain-based statistics. We have really tried it on this that's now.
Yep, Sri. Unfortunately, it really is your internet connection that you're coming in and out.
Yeah,
So
I'm
that
sure.
was hard to understand. Sorry about that.
Okay.
Does anyone have any more questions? We can keep trying, or things they want to share with support vector machines and explainability. Does anyone have any experience with that? It's interesting because the modern models, there's a lot of stuff happening with explainability and reducing the size of models too to make them more performant. So it's kind of interesting, like the Stillbert and so forth. It's interesting to see this happening with SVM as well.
I think here, more than explainability, it is the interpretability which brings a value, because if you have a smaller data forming the same hyperplane and then trying to not change the confusion matrix. So I think that's what I think this idea brings in, right?
Yeah, exactly. But what I'm wondering is, can you explain what SVM explainability means? Does it mean looking at the data points on a graph and seeing how they're divided, or what does it mean for this binary classifier? What does explainability mean? Practically, what are you looking at? Does anyone have any idea? I mean, you're looking at the words, or it's not the words, but it's somehow you see the data that caused the classification or something?
No, okay. From what I understand, there is okay. There are two data points, right? You have packets per second, and then you have bits per second, and we are trying to learn a linear relationship there. And when you try to draw a linear relation using SVM classifier, there are too many points trying to form the decision boundary, right? And that makes the interpretability of how much to store becoming very hard. Let's say tomorrow you want to do a RBF kernel, and then put on an embedded thing, and then put it on the edge. It tries to make more points. So here I think the intention is to try to reduce the number of features on which the decision boundaries can be drawn upon, right? And when you have very less number of vectors to describe a classification or a segmentation boundary, it helps more in terms of let's say a network administrator looking at the thresholds and making sense of, okay, this is why this happened, right? So that's the notion here, is what I'm guessing.
Okay, thank you.
Yes, you're right on that. So the main idea here was to reduce those number of support vectors. So if we can develop a model with much lesser support vectors with the same accuracy, why go with a larger number of support vectors? This is just in initial stages, so we have a lot more to go on this.
Yeah, and what are your next steps? We just have about 30 seconds.
So we have initially tried it only on the linear SVM models, right? So we are planning to make it work on the RBF kernel so that we can deploy these RBF kernel models in ours, with much lesser support vectors, which would be a space advantage for us. So that is the current plan, what we have.
Great. Thank you. Appreciate your time. And we're going to go into the post discussion stuff now. And
Thanks for the opportunity.
Real quick. Thank you. And I just want people to be aware of the next session, which is next Thursday at the same time. And we have actually more presentations at that point. Because we have backlog, a couple of them we might not get to. But now we've been going about an hour and 20 minutes. We can have 10 minutes if anyone has any questions they have, anything they want to share, any suggestions for how this was run, so that next Thursday we could do this even better. Please just speak up now. Anything, anyone. Okay. Come on, somebody.
Well, I'll just say that this was a great session, Darren. A great idea to pull it together, and great job getting all these folks to share what they're doing.
Thanks, Sam.
Yeah, I think even I felt that this format, the outline you have put made it very easier for people to come in a very short time and then present it and then exchange very specific views, right? Even the image idea, when I saw, there are a lot of creative thoughts coming, like what if the label was very different on the image, right? We are drawing a contact, but you want to relate to your brand image. I think it's very creative. It's very thought provoking in the objective of the session. I think it was a very nice template, is what I felt.
Yeah. So what was that idea with the brand?
Okay, I was just telling that orthogonal means okay, not to connect exactly the image to the object, the word that you are searching, but let's say that a close by word, right? A brand of a product, right? A condog buy some 2 or 3 brands, right?
Okay.
So like, see, many times I see that sometimes there's a question asked about what is the application, industrial application of it. Okay, let's say I see pizza shops having order number written to it. Yeah, pizza is pizza, everything will be there, but how can you relate to your order number, right? So there are a lot of not exact word words, what to say, matching to that, but the nearby words that could also bring a lot more value in real time, right?
Absolutely. Absolutely. I
Yeah.
mean, machine learning is no exact science. So
Yeah. No, I'm not worried about
I
the
don't,
accuracy. Yeah, agree.
yeah.
But what you're
There,
thinking maybe is that that it shows that pizza is very closely related to corn dogs, right? And so, if you did a keyword search bringing back image and you already had a classifier, right, you could see the ones that are not corn dogs with your classifier, and
yes.
find related kind of sort of like it's like a word vec, or a word embeddings where you find related words. Well, you could kind of do that with this. Is that sort of what you're thinking? Or was
Yeah,
I way off?
yeah, yeah. No, that is perfect. Like, somebody else also gave one thought, right? Like, how can you cluster them, right? The clustering is a very powerful example for personalization, right? I may be searching corn dog with some very different intent in mind. Somebody else may be searching corn dog with a different intent in mind. So again, these are all very powerful application use cases that come, right? One is the how part of it, but definitely the application part of it, this kind of sessions provokes a lot more ideas, right? Even we saw in the NLP example, like how he was trying to talk about Spanish. Many times I have wondered, see, Indian languages are very, very descriptive in nature. Like, we have very, very different phonics which doesn't mean the same, and different phonics to have different meaning. So there, the word to vector, there's a less ambiguity in the language space. But English being a very
Hmm.
collapsed language space, we get those ambiguities, right? But no matter what, research advances first in English. Today, I think a couple of days before, I read a news that what to say, Facebook was trying to launch that direct different language to language without going via English, right? I think once,
Hmm.
it means all these things will help. These are all very emerging ideas, and then it will latch on to us, making all the solutions work better, right? What I have seen is, like, what seems not working 2 years before, I think lot happens within 2 years, and then many of our ideas come true. That's what I find. Right? Like, that means that
Yeah.
there are very different insights to take even from applied ML exchanges, and this is a very great forum where, yeah, yes, we did some experiments, but there are many insights. Like, what it means, that the other question which was asked on deep neural networks, right? ResNet. Why ResNet as a framework? Because you can scale down for the number of applications, or you can scale up for the number of applications. It can fit into a embedded space. Like, you can also think an IoT company trying to put a security chip on the IoT device itself to see whether I'm varying with myself. So there are many, many possibilities that are there. I think these sessions really provoke that creativity, is what I feel.
Yes. Darren, tomorrow in the panel discussion session, I expect you to share your secret sauce, how you got all those people presenting.
It's just because so many people want to. I mean, they were just enthusiastic. But yes,
Yeah.
I will, of course. And I think that it's interesting because when you put machine learning through the prism or the lens of practice, right, real practical practice, you see how you could put together many different pieces in different ways, and you also get the context of when to use of why someone used what model, and just because of practical affordances, right? And it's very far from the sort of academic approach, or it kind of filters what's important, and then gives you this fodder for creativity, for putting pieces together. So when I'm trying to solve the reason I do all this is because to get all this fodder for creativity when I'm trying to solve a problem at work, I have all these bits and pieces from all these different areas that I might be able to draw in on, and I have those because of this lens of sharing of practical projects. So that's why I
totally agree with that. It's really, the work in this field is really about thinking of creative ways to solve your problem, and that's really the exact best thing to do. Look at other people, what they are doing, and even completely different areas. It really helps.
Yeah, it focuses what's important as well. And everyone's saying, well, machine learning doesn't work. Oh, machine learning works. It's amazing. The bots are going to take over the world. And then in between, what you have is, in practicality, you can make it work good enough. And sometimes good enough can be a hell of a lot of leverage in an enterprise. And good enough may include using multiple different types of machine learning at the same time combined. So, does anyone have anything else? Thoughts coming out of this? We have just a couple more minutes. By the way, this is sort of the style of our. This is nothing new in a way. This is nothing new. This is very much the style of the meeting we're having in 30 minutes. The NLP embeddings calls. It's a small team, a small group though. We've been doing it for a long time. But anyway, anyone have anything else they want to share or thoughts before we close out here? Okay. I think, Mia, you wanted to close things out?
Yeah, hi guys. Darren, thank you so much for organizing this. This was awesome. And thank you everyone for sharing. Nicholas, Nick, Abdul, Kai, Shri, and Darren, your hosting was awesome. And thank you everyone for attending and for your great questions. This video will be available on the session page. And so be sure to reference that if you'd like to take a look at people's projects again. The session we'll also be doing another one, as Darren said, another version of this this lightning share next week at the same time. So those are all listed on the same session page, and the link to join will be there as well. So be sure to check that out. I also want to mention that the session was 100% from the community and from our study group host, Darren, and he will be on a panel tomorrow along with Kai, who presented today. And so if you'd like to hear more about what it's like organizing and getting groups together, be sure to check that out. That'll be at 8 a.m. tomorrow morning, and that'll be on the agenda. So thank you so much again. This was fantastic. I'm looking forward to next week, and see you all soon. Thank you.
One quick thing, if you don't mind, Mia, just one quick thing. If anybody on this call has or knows of somebody who wants to share some NLP work in this very similar way, let me know. Get in contact with me, and we'll get you in on our Thursday calls just to do a share. So thank you.
Great.
Thanks for helping. Thank you, Mia, for helping.
Thank you.
Out.
Bye.
Bye, everyone.
Thanks, Darren. Thanks.